Today we're going to talk about half-lives, and half-lives are going to apply when we are looking at nuclear reactions, and they help us describe how much time it takes for half of a radioactive isotope to decay. Now, it's not that this radioactive isotope is totally going away, it's just not radioactive anymore. It's the amount of time it takes for this radioactive mass to decay in half. So half of it is not radioactive anymore, and half of it still is radioactive. And then, in that same amount of time, its half-life, half of what's left is going to decay again. And it keeps decaying and keeps decaying and keeps decaying, again, in increments of half throughout this course of the time, that you have such a small amount left over that you can say that that material is no longer radioactive. And depending on the material will determine how much time it takes to actually get to that point. The half-life is specific for that particular type of material. And there is an equation that we can use in order to figure out a lot of different portions of this radioactive decay. So the equation that we're going to use is A is equal to A naught 2 raised to the nth. A is the new amount, so it's the amount of material that is left over after your time of decay. AO is your original amount, the original amount of radioactive material you had, and N represents the number of cycles. Now, N can actually be broken down even further. The number of cycles is the total time that this decay went on for divided by the half-life of that particular sample. So again, the number of cycles is calculated through the amount of time that this decay went on for divided by that particular substance's half-life. So we really can solve for 1, 2, 3, 4 different variables within these types of problems. So today we're going to solve for 2 of them. And again, it's kind of just manipulating which variable you're trying to solve for. So example 1 says after 16 days, 8 milligrams of an originally 128.0 milligram sample remains. What is the half-life of the sample? So I like to pull out the information I know. So I know after 16.0 days, so the total time that this decay was going on for was 16 days. And it says 8.00 milligrams of an originally 128 milligram sample remains. So it's telling us that 8 milligrams remains. So that is our new amount. That is A. And it told us that our original sample, so that's A naught, is 128.0 milligrams. And it's asking for the half-life. So what we're going to do is we're going to plug it into our equation and figure out how we can solve this. So again, we have A being 8.00 milligrams is equal to our A naught. Let me zoom in on this just a little bit for you. Is equal to our A naught, which was the original amount, which is 128.0 milligrams, 2 raised to the nth, and the nth is time over half-life. So we do have a total time, but we don't have a half-life. So for this particular problem, we're solving for a variable in an exponent. And so we're going to have to do a little bit more complicated algebra here, but we can totally do this. So my suggestion is to first do some cross multiplication here. And so I'm going to put this over 1, and so I'm going to get this is equal to that right there. So I'm going to have 2 16 over x, 2 raised to the 16 over x times 8 is equal to 128 milligrams. So I want to get this x factor by itself, so I'm going to start dividing over. So I'm going to divide both sides by 8. And so with that, I get 2 raised to the 16 over x is equal to 128 divided by 8. And that comes out to 6. So now I have to figure out a way to get this x out of the exponent. And we can do that through the natural log, ln. And so if we take the ln of both sides, we are taking this exponent and putting it out in front of the ln. So if we can follow me up here, our new equation is going to look like this. 16 over x times ln of 2 is equal to the ln of 6. Now you should have an ln button on your calculator. I'll show you where it is on mine. It's right here, capital L, capital N, and you just click it before you put in the number. So if I do the ln of 6 in my calculator divided by the ln of 2, I can get 16 over x is equal to, let's see, oh guys, I'm so sorry. 128 divided by 8 is not 6, it is 16. That is my fault, so sorry. Alright, let's try that again. So the ln of 16 divided by the ln of 2 comes out to 4. Alright, now, again, we can cross multiply. So we get 4x is equal to 16, and so x is equal to 4. Now, we have to go back and figure out, well, what does 4 mean? The question asks, what is the half-life of the sample? A half-life is an amount of time. It's the amount of time needed for half of our sample to decay. So if we look at our other time factor, we were in units of days. So that means that we should have units of days at the end of our half-life. Again, we want to look at significant figures always. 3 significant figures, 3 significant figures, 4 significant figures. So 0.00 days is going to be our final answer. So this is probably one of the harder ones to solve. Let's go ahead and do one that might be a little bit easier, just solving for a different factor. Alright, so this one says, the half-life of ZN71 is 2.4 minutes. If one had 40 grams at the beginning, how many grams would be left after 7.2 minutes has elapsed? So again, if we think of our equation, A is equal to A naught over 2 raised to the n, we have different factors in here. So A being the amount left over, so it says we have a half-life of Zn is 2.4 minutes. If one had 40 grams at the beginning, how many grams would be left over? So it's asking for how many grams would be left over, so that's our x. And then we have A naught, which is the amount we started with. So in this case, it says that we had 40 grams at the beginning. Then remember, we need the total time of this decay, and we need the half-life of this isotope. So it told us that the half-life of ZN71 was 2.4 minutes, and it said that it was left for 7.2 minutes, so that is our total time. So I'm going to go ahead and plug in these numbers. Let's see what we get. If you have a fraction that has a numerator and a denominator in your exponent, I would go ahead and do that division before you start trying to do algebra. It might make your life a little bit easier. So this is going to simplify to x is equal to 40.0 divided by 2 raised to the third. All right, now we can just go ahead and do this division. We don't really have to manipulate any variables because we're solving for x on one side of the equation. It's already set up with x by itself. So I'm going to do 2 raised to the third, and that's going to come out to 40 over 8. And then I'm going to do 40 divided by 8 in order to get x is equal to 5. Now again, if we look at all the numbers given to us in the problem, we have 2 sig figs, 3 sig figs, 2 sig figs, so we want 5.0. We always want to go back and figure out, well, what does this number mean? So the question asks for how many grams would be left over, so that means that our x has to be units of grams. So that's our final answer.